Welcome back to another lesson in MCV4U. Today we'll be looking at multiplication of a vector by a scalar. So if you recall the definitions that we've looked at previously, a vector is a quantity with magnitude. So again, a quantity with magnitude. So length and size are some examples, and it has a direction. So it's magnitude and direction. That's what indicates that it's a vector. A scalar quantity is a quantity with a magnitude only. So example, mass, speed, volume, or energy. So here it says given a vector v and a scalar k, where k is an element of real numbers, then the scalar multiple of vector v is the vector k times vector v. So again, multiplying a vector by a scalar can affect the direction and the magnitude of a vector. Again, provided that the scalar that's being multiplied is not equal to 1. So here, if we look at this first example, it says given the vector v, draw the following vectors. Okay, so we're given the vector v here, and it says for the first part one, it's 2 times vector v, or 2v. And so here we see that vector v, if we're drawing 2 vector v, we're going to draw that pretty much twice. So 1, 2. So that would be 2 vector v. If we're here, we have, and the direction is the same here as we see. For b, it's negative 3v. So here, again, the direction is now the opposite, and we're going to draw 3 of vector v. So here we have 1 negative vector v, 2 negative vector v, and 3 negative vector v. For c, we have half of vector v. So here, in terms of vector v, it expands through these two boxes. So here, for half of vector v, it'll only cover one box here. And then finally, we have negative 1/4 vector v. And so again, direction is changed, and it's 1/4 of the original vector. And so look, something like that. And so if we look at collinear vectors, again, vectors are collinear when they are parallel or lie on the same straight line. Two collinear vectors can be translated so that they lie on the same plane. Again, the terms parallel and collinear are used interchangeably. So again, you might see parallel vectors or collinear vectors, and those mean the same thing. So here, note two vectors, vector u and vector v, are collinear and share the same line if and only if it is possible to find a non-zero scalar k such that, again, vector u will equal to the scalar, which is k, times vector v. If we continue, again, a unit vector is a vector having a magnitude of 1 unit. So an example here is if we have, again, 2 times, again, that 2 times x, again, is equal to 2. Again here, 2 times x is equal to 2 times 1, which is equal to 2. And same thing here, if we have 5y, again, magnitude, vector having a magnitude of 1, 5 times y will equal to 5 times 1, which is equal to 5. Okay, so let's look at the example 2. It says the vectors vector x and y are unit vectors, again, meaning that they have magnitude of 1, that make an angle of 42 degrees with each other. Then calculate 2x minus y. Okay, so here, if we look at, simply to start, if we look at x plus y. So here, if we look at our vector x plus our vector y, and unit of 1, it would look something like this. Okay, but again, here, what we're looking for is we're looking for 2x minus y. So here, we have to construct, again, 2x minus y. So 2 times the vector x minus y. Here. Now if we draw it, again, 2 times vector x. So this is 1 vector x, 2 vector x. And again, negative y, again, means that it's moving in the opposite direction here. So here, again, our resultant vector will be right here. And so resultant vector is equal to 2 times vector x minus vector y. So here, this again is 2 of times vector x. And here now, that's 2 units, and vector y would still be 1 unit. Here we see that, again, our angle over here is 42 degrees. Again, which means that we know that this angle would equal to 42 degrees as well. Okay, so to find, again, our length here, we're going to use cosine law. And so here, r squared is equal to 2 squared plus 1 squared minus 2 times 2 times 1 minus cos 42. And so that's equal to 5 minus 4 cos 42. Here, r squared is equal to approximately 2.0274. And therefore, here, r is equal to 1.41. And so that's the magnitude. Again, the magnitude of our resultant vector is 1.41. And now what it wants us to do is, again, determine the direction of 2x minus y. Okay, so here, I'm going to just take this picture that we drew, make a copy so we can copy it down here. And so here, again, we want to look at the direction. And to find the direction, you're going to use sine law. And we're going to find this angle here. Okay, so here we see that sine theta over 1 is equal to sine 42 over the value we just found for our resultant vector, which was 1.41. So here we see that sine theta is equal to sine 42 over 1.41. And so theta is equal to 28.6 degrees. We can write that it is clockwise of 2 vector x. Okay, and then our third example, again, it says given 4 vector x minus 4 vector y is equal to 7, find 2 vector x plus 5 vector y. Again, what we don't know this time is we don't know the angle between vector x and vector y. So we do not know the angle between vector x and vector y. Okay, so here we can do our first drawing. We do know that 4x minus 4y is equal to 7. And so here, again, 4x, we drew 4x here. And if we draw 4y, so this would be 4x plus 4y. Again, these are both unit vectors, and these are represented by the little top hat there. And so these are both, again, unit vectors. So 4 times 1 would give us 4, and 4 times, again, 1 would give us 4. So here. So instead, we are looking for 4x minus 4y. So now we'll draw the 4y in the opposite direction to make it negative 4 vector y. Again, still 4 units. And we know that the resultant vector provides us with 7. So the resultant vector is equal to 7. Okay, so we don't know the angle in this situation. Okay, so here, again, we're going to solve for the angle here. And here we're going to use cosine law again. And so 7 squared is equal to 4 squared plus 4 squared minus 2 times 4 times 4 cos theta. Okay, so 49 is equal to 32 minus 32 cos theta. So that 17 is equal to negative 32 cos theta. And cos theta is equal to negative 17 over 32. And therefore theta is equal to 122 degrees. Okay, so here we get theta is equal to 122 degrees. Again, we see that our diagram isn't really to scale, but again, sometimes after you solve, you'll realize that your diagram is not to scale. But again, we don't know what type of angle it is, so that is okay. So again, sometimes after solving, you realize your diagram, you realize your diagram is not to scale. Again, it's okay since there is no way of knowing what type of angle it is. So again, we don't know if it is acute or obtuse. Okay, so now that we got our value, again, we need to find, again, we're trying to find 2x plus 5y. Okay, so here we're trying to find 2x plus 5y. Okay, so here we have 2x. So here we'll draw a little bit smaller. So there's space here. So 2x, so 2 vector x plus, again, 5 vector y. And so we're trying to find, again, what that is here. Okay, so here, again, we can move this 5y, and so that we can, so that's easier to calculate. And again, our resultant vector will be here. Okay, so we know that our entire angle here is 122 degrees. Okay, we don't know our theta here again, but we know that this angle here will be 180 minus the 122. Again, understanding that we're using this method of the parallelogram. So again, this will be 58 degrees. And so here again, we'll find our resultant vector using cosine law. So r squared is equal to 5 squared plus 2 squared minus 2 times 5 times 2 cos 58. Here, when we calculate it, we get r, the magnitude is equal to 4.3. Okay, so now we need to determine the direction. Okay, so here, again, we'll use sine law. So here we have sine theta over 5 is equal to sine 58 over our resultant vector that we just found, which was 4.3. Sine theta is equal to 5 sine 58 over 4.3. Sine theta is equal to approximately 0.9861, and theta is equal to 80.4 degrees. So here we see that, again, 2 vector x minus 2 of vector, or minus 5 vector y has a magnitude of 4.3 and is 80.4 degrees counterclockwise of vector 2x.